our plan today is to look at some of the examples, some/all, depending on timing, on the front side of the notes. And then you'll notice as you look at the examples on the front side of the notes, they're ones that have logs in them. So we're going to be using our log properties to try and solve these. And then Monday, I'll look at some of the examples on the back, and they are the ones that are in exponential form currently. And we'll look at options of how to solve those. Now, you'll see up here a set of 3 steps. They're not going to work perfectly for every problem, but they're kind of a guideline you can use to help you through. Bless you, yes. So, solving equations using logarithm properties. So you know those properties we learned yesterday. Product rule, quotient rule, power rule.
Yeah.
Change of base, maybe. I don't know if we'll use that one or not, but those are the rules we're talking about. So, step 1, the suggestion is to rewrite both sides. So, assuming we're looking at a problem where both sides have logarithms, rewrite both sides as one logarithm on each side. Okay? If you can get this into a scenario where you have 1 log equal to 1 log, then once you have 1 log equal to 1 log, going to be the same base, the insides are equal to each other. And so you can just set the insides equal to each other and solve the equation from there. Okay? On the ones where we don't have logs on both sides, and you just have a log on one side, then we're going to go back to that left, right, middle, and change things to exponential form.
Yeah.
Okay, so those are kind of the 2 options we are looking at today. So let's look at example A. Log base b of 5 plus log base b of 4 minus log base b of 2 equals log base b of x. That's a lot of logs.
Log base b of 20 divided by log base b of 2 equal to log base b of x. Because
kind of, yeah.
Add the 2, or the 2 that are adding would be multiplied eventually.
So on the left, it suggested we get everything combined. Well, we have 2 logs being added and a log being subtracted. So this is log base b, because they're all b's. The log of 5 plus log of 4 is going to become 5 times 4. The minus log of 2 is going to be divided by 2. And it still equals log base b of x.
So would you not multiply that yet?
I am. I was just kind of showing the step. So a number didn't just appear out of nowhere that you didn't know where it came from. So when you clean up 5 times 4 divided by 2, that's going to be log base b of 10 equals log base b of x. Well, if you have log base b of 10 equals log base b of x, guess what?
X is 10.
X is 10.
Heck yeah.
Okay? Once you have
Same base.
log, same base, equal to log, log equal to log, base is the same, the insides are the same. Now, we do need to be aware of what I would call extraneous solutions.
No.
Okay? Now, when we dealt with fractions, extraneous solutions were anything that made the denominator equal to 0.
Yeah.
When we deal with logs, the inside of a log can never be negative.
Yes.
Well, does plugging a 10 into the original equation ever make a log negative?
No.
No, because the only place you plug it in here is log of 10. 10 is fine. But you have to have that in the back of your mind that I need to be checking for extraneous solutions. Okay? That was the easy one to get us started. Ready for B? Okay. 2 log base 5 of x equals 1/2 log base 5 of 144 minus log base 5 of 3.
Move the numbers to make them exponents.
Okay, start with our power rule.
Yeah.
Move those numbers to the coefficients. So
Log base 5 of x
log base 5 of x squared equals log base 5 of 144 to the 1/2 minus log base 5 of 3.
Or just square root. Yeah, square root.
Okay, I was waiting for someone to tell me. 144 to the 1/2 is equivalent to the square root of 144, correct? Okay. So now I have log base 5 of x squared is equal to log base 5 of, what is the square root of 144? 12 minus log base 5 of 3.
Then, on the right side, it's just 12 divided by 3. You get log base 4. And you gotta take square root.
Okay. Log base 5 of x squared stays on the left for the moment. 2 logs being subtracted can be rewritten as 1 log where the insides are divided. And we know that, so it's going to be 12 divided by 3. We know 12 divided by 3 is 4. What do we have happening at this point?
X is 4. 2, right?
Okay. So technically, it's log base 5 equals log base 5. So we can say that x squared is equal to 12 divided by 3, which is 4. If x squared equals 4,
Take the square root of both.
take the square root of both sides.
X equals
And x equals what?
2.
Plus minus 2, but it'd just be 2 because you can't have negative.
Okay.
It'll just be 2.
Officially, I'm going to say plus or minus 2 because we always need to consider all options. And when you take the square root in an equation setting, it's plus or minus.
So
Now, where would you be plugging it in back here?
the X, where the X is.
If you plug it in where the x is, you're going to have a
Negative.
negative x, negative 2,
Ooh.
which would be a problem.
Get it up.
So what's the only answer that works?
2.
The 2.
Do we need to put anything about how negative 2 can't work? Or
No. And here's my opinion as a teacher. Should I see positive and negative 2 listed as possible answers? I should, because that's part of your work, that you got those answers. But then by you going on and saying, okay, x just equals 2, it's kind of unspoken that, okay, you realize the negative 2 won't work. It doesn't check. Okay? Okay. We ready for C?
Yeah, I guess. Oh, we have to use left, right, middle. Right? No, hold on. Never mind. My brain saw that wrong.
I don't know. I'm not there yet. Okay. Log base 4 of x plus 6 plus log base 4 of x equals 2.
X squared plus 6x.
Okay.
No, yeah.
Yeah.
On the left,
They won't.
2 logs being added
Yeah.
could be rewritten as 1 log where the insides are multiplied. Now, on the right, just equals 2. There's no log there. Now, you guys had already said x squared plus 6x, so let me rewrite that real quick.
I agree with that statement.
Log base 4 of x squared plus 6x equals 2.
No.
Now, okay, it was already stated, but what's the catch here?
Are we,
Hold on, what's the catch?
you can use
Do I have 2 logs where I can just drop the logs?
No.
No. I have 1 log equal to a number, so we have to take a different route. And what is that route?
Is it left, right, middle?
It is left, right,
Yeah.
middle.
Yeah. Yeah.
LRM is my abbreviation as a reminder. In other words, I can't solve this in its current form. I have to change it.
It would be
So how do we get a log equation to become an exponential equation?
4 squared is equal to x squared plus 6x. Let's get a peek.
Okay.
Oh,
Are you guys with them?
they better
The 4 on the left raised to the 2 on the right equals the x squared plus 6x in the middle.
16.
4 squared is
16.
16.
I got it right this time.
So 16 equals x squared plus 6x.
Subtract 16 over, and then that's when you can you I don't know if you factor up or not, but factor it.
That's what we assume we're going to do at least.
Yeah.
Okay. So hopefully you're seeing a quadratic here, yes?
Yeah.
And you end up with 0 equals x squared plus 6x minus 16.
Or,
Does it factor?
I don't know, give me a second.
Yes.
Yeah, it does. 8 and 2.
Okay, factors into 8 and 2 with a positive 8, negative 2.
I agree. And then you have to flip 3 7 equal to 0.
Officially, it's set each factor equal to 0. So x plus 8 equals 0, x minus 2 equals 0.
X equals negative 8, positive 2.
We do the math.
And then
X equals negative 8 and positive 2.
X and positive 2. And then, hold on. We ain't telling you negative 8. It does not work.
Why does negative 8 not work?
Negative. Because negative 8
Okay.
plus 6.
And now, let me make sure we're not, okay, negative 8 doesn't work because when we plug it in, it makes the log negative. With that being said, depending on the problem, could there be a negative answer?
It could because
There could be a negative answer depending on the problem. So don't just assume negative answer, it doesn't work.
I'm guessing that's
In this case, negative 8 doesn't work in either place when you plug it in. Now, also, don't just assume a positive answer works.
What?
Because, for instance, if this had been 2 minus 6,
Oh.
that would make the log negative. So you need to check and see what happens.
I quit.
I just don't want you falling under that assumption of positives will always work, negatives will never work. Okay, let's look at D. Log base 9 of 5x minus 2 minus log base 9 of 3 equals log base 9 of 2x plus 1.
Right. X minus 2 divided by 3.
No.
5x
Okay.
minus 2 divided by 3.
2 logs being subtracted on the left can be rewritten as
Division.
1 log with division. So on the left, log base 9 of 5x minus 2 divided by 3 equals log base 9 of 2x plus 1. Okay.
And then you could just, it's 5x minus 2 divided by 3 equals 2x plus 1. I don't know.
Okay. I have log base 9 equals log base 9.
Wait, was that right?
So logs equal to each other with the same base. You can set the
It's,
insides equal to each other. So 5x minus 2 over 3 equals
2x plus 1.
2x plus 1.
Multiplied by 3.
Okay. We don't like solving equations with fractions in them. We never have, we never will. How do you get rid of a denominator so we don't have a fraction?
Get it out of here. You gotta multiply that thing.
So this is dividing by 3. We're going to multiply by 3.
Minus 6x plus 3.
Now, on the left, when I multiply by 3, the 3's will
Cancel.
cancel. You have 5x minus 2. On the right, when I multiply by 3, I need to
Do each piece.
distribute. So 3 times 2x plus 1 becomes
6x plus 3.
6x plus 3.
And then just combine like parts.
Combine like parts to get, I would say, x's on one side, numbers on the other side, right? This is more middle school. This is not x squared equation, is it?
No.
So
I put all my x's in the CapEx.
I personally, would subtract 5x over to the right, and I would then subtract 3 over to the left is what I would do. But so then we end up with what?
X equals negative 5. It does not work.
X equals negative 5.
No solution.
It doesn't work?
No, because the 5.
5
X.
times negative 5 minus 2.
Okay, right there, folks. Becomes negative 25 minus 2. I have the log of a negative value when I plug it in.
Yeah, you do.
Okay, so -5 doesn't work. Since I have no other options, we get to say
The solution.
no solution.
Yay. All that work for nothing.
Okay.
Oh.
Um,
Oh. Are we? No. Are we having to foil? Oh.
I don't know. Not necessarily. Depends
Okay.
on what we're. Okay, guys. There are a couple different ways we can go, so it'll be kind of dependent on what you guys see. But
Oh, wait. Hold on. Oh, wait.
3 log base 3 of 3x minus 2 minus log base 3 of 3 equals 2.
So, couldn't you leave that 3 out front and then just do 3 up close? No, because then you'd get stuck there.
I would suggest you start off by thinking about log base 3 of 3.
Log base of 3 of 3.
Okay.
Okay. Yeah, I see it.
Log base 3 of 3.
Oh, wait. It equals 1.
Are you guys with them?
Attaboy, Paxton.
Log base 3 of 3. That's that property, right? When the base and the inside are the same, it's equal to the exponent, which my exponent is just 1. So here's my suggestion, is that we rewrite this equation as 3 log base 3 of 3x minus 2 minus 1 equals 2.
Are we going to eventually move that power in the next step?
And that's what I was just debating. We can do it with or without moving the power. And that's what I was double checking.
So if we move the power now, we foil.
I'm never foiling personally.
Okay, so it doesn't matter then.
I'm not doing any foiling in this problem,
That works
so
for me. Okay, whatever sticks on your cracks is. Wait, just add the. Are we gonna add the 1 over?
okay. So definitely we want to add the 1 over to get this log by itself. Okay. If we go ahead and move the 3 up, which is probably the better suggestion. Okay. Huh?
And so then left right.
No, not necessarily. I don't know what else it is.
Wait.
Nope, that's right.
I guess it would be.
It's gonna happen.
Yeah, either way. Okay. Sorry, my mind was. So, log base 3 of 3x minus 2 raised to the third. If we move that 1 over, this is equal to
Trace.
3.
Oh.
Okay? Now, left, right, middle to get out of here,
3 to the 3rd.
since we have a log on one side and not on the other side.
Yeah. 3 to the 3rd is equal to 3x minus 2 cubed.
So 3 on the left raised to the 3 on the right equals 3x minus 2 to the third. Okay. And this is where
Oh.
Logan was stressing about having to foil, and I said, I'm not foiling.
Yeah, I'm good with this then.
Okay.
Wait, well, hold on. Will we ever have to foil? More than likely not.
I can't guarantee one way or the other. Okay. On this one, I just know I don't need to foil.
On
So
tests.
here, guys. One option would be take 3x minus 2 times 3x minus 2 times 3x minus 2. Yuck. Okay. That's just, it's not going to be pretty, because then you still have to try and backtrack and solve it. 3x minus 2 raised to the third. How can I get rid of that third? You can take the
Cube root.
cube root.
Oh, God.
If you take the cube root on one side,
You gotta do it to the other.
you take the cube root on the other side.
Which just leaves you with.
Now,
Oh my goodness.
what's the cube root of 3 cubed?
3?
A cube root and a cube are going to cancel each other out, and you're going to get 3. Or 3 cubed is 27, but the cube root of 27 is 3. What's the cube root of 3x minus 2 cubed?
3x minus 2.
3x minus 2.
I will be darned. This works out beautifully.
3x minus 2 equals 3. Solve.
I will be absolutely darned.
Add 2.
5 equals 3x.
5 equals 3x.
So x equals 5/3.
Divide by 3. X is equal to 5/3.
It works.
Do a quick glance. If I plug in 5/3 here, 3 times 5/3 is 5. Excuse me. Minus 2 is still positive. So it appears to be working.
Yay!
Okay? It's taking all of our equation skills that we've learned over the years and putting them together, right? Okay. One more here on this side.
Oh wait, there's 2 sides. I was excited. I thought this was the last one.
Okay, what are you doing first?
I would combine them. In my thoughts.
But before you combine them,
Do you have to move the power?
you have to move the power. You have to move that 1/3 up.
Wait, hold on. Is this just like a personal choice here to move the power? Or do you have to move it?
You can't combine the logs when there's a number out front. It has to be up in the power. Okay, so it's not a choice, it's a requirement.
It's a law.
Yeah. So log base 4 of x to the 1/3.
Root of x, or cube root of x. Yeah.
Okay, so I'm going to write this as the cube root of x plus log base 4 of 5 equals to 1/2. Now that I've moved that power, 2 logs being added can be rewritten as 1 log where the insides are multiplied. So I'm going to write it as 5 times the cube root of x equals to 1/2. Okay. Now what?
Left or middle?
Right.
We have to get it out of log form. So we're looking at left, right, middle. A 4
To the half.
to the 1/2 left, right is equal to 5 times the cube root of x is your middle.
That's a. Well, I'll be darned.
What is 4 to the 1/2?
2.
It's the square root of 4. And the square root of 4 is 2. So now I have 2 equals 5 times the cube root of x.
Just subtract 5.
Well, divide by 5. Divide by 5.
If I have 5 times the cube root of x,
Oh yeah.
and I want to get the cube root by itself, we're going to divide by 5.
And now you cube it.
I forgot.
And so then I'll have 2 divided by 5 equals the cube root of x. How do we get rid of a cube root?
Cube it. Yeah.
You cube it. Now,
Wait. 2 this times 2 this times 2 this.
or what's 2 to the 3rd?
8.
8.
Over what's 5 to the 3rd?
125.
So 8 over 125.
Yeah, that would work.
And then the only place you plug it in, it's just plugging in for x. So it works.
I'll take it. Alright.
Okay.
Oh, so. I got used to that one page when we went for notes yesterday.
Okay. Here's the deal. If I stop now, you're going to waste the next 7 to 8 minutes
I'm
probably.
not though. I'm actually gonna do homework.
Or I can go ahead and at least do maybe one from the back. And then that's less I have to do on Monday. And
Alright,
maybe
let's
work
do
time on
one.
Monday.
Let's do one. Let's do one.
Or I could just totally stop.
Let's do.
I don't know.
Let's do one. Let's do one.
Oh wait, are we doing these backwards?
Okay. On the back.
No.
This allows us to pull the powers down because the power
Now.
logarithm.
Please listen. Gentlemen. Okay. On the back, the difference as you look at the backside. There's no, well, I take that back. There's one log here. Most of these are exponential equations. Okay, so we're going to take a different route with these. Okay, they throw all these equations into one chapter or one unit, one lesson. There's what I'm looking for. So we have to take a different route. Okay, with these problems, the bases won't match. We've talked about some where if you can get the bases matching, then your answer is in the powers, those type of things.
Yeah.
This isn't going to happen. Okay, this is 2 to the x, but 53 is not 2 to some power. So what's the plan when we can't get the bases to match? So what we're going to do is we solve by taking the log of both sides. Officially, you can use log base 10 or natural log. Basically, you want to use a calculator button. That's what's going to make life easiest. This allows us to use our power property and then solve for x in the process. Okay? Let's look at A. Okay? It's a little more basic here. I can't get 2 and 53 to be the same base. X is in the exponent. So I'm going to take the log of both sides. Which taking the log just means?
Put a log in front of it.
Yeah. Log of 2 to the x equals log of 53.
It's
Okay.
1.
What can I do with that x?
You can put it out in front.
Okay.
Oh, yeah, you can do that.
So we're going to reverse the power property here.
And then you can just
And we're going to take that x
divide.
and put it out front. So then I have x
Log of 2.
times log of 2 equals
Log 53.
log of 53. And I just realized, I don't know why I wrote that 53 so small up there. It's just a regular log of 53.
You were hoping it wasn't
So now
exponential.
x
Okay.
just equals log 53.
Okay, so this is a basic equation. If it's x times log of 2, how do you get x by itself?
Divide by that log of 2.
You divide by log of 2. What you do on one side, you do on the other side. So your answer is going to be whatever log of 53 divided by log of 2 is.
5.728
I agree.
approximately.
I was told 5.728,
I second that.
Approximately.
and my answer key agrees too, so sounds like we're good. Okay, so that's kind of the general theme we're going to be using when the bases don't match. Is we're going to try and get the power by itself and take the log of each side. Okay? So, Monday my plan will be to look at some more examples and then maybe give you guys some work time.
So it sounds like we can get
We'll
through
see.
7 through 16 without calculating.